In this video, we're going to take a look at the local rotation axes located underneath your particle animator. Now, these allow you to specify an axis around which your particles will rotate as they move through space. It sounds really cool, and it actually is really cool for things like any kind of magical effect, or if you need like a vortex of particles. Let's go ahead and just kind of give a quick demonstration. If we select our particle game object. So I'm grabbing the game object to which my particle system was parented, just so we don't have our little annoying particles, polygons in the way. I can go underneath either one of our world or local rotation axis properties, but I just want to point this out. Currently, I'm using local velocity, and so I'm going to use local rotation axis as opposed to world rotation axis. This will just be to get the point across, and in a moment I'll go over the difference between the two. So currently I am moving down the x-axis. This means that if I was to take my local rotation axis and start increasing x, we're actually getting a difference, but it's really hard to see because we're moving these objects, we're revolving them around the same axis they're traveling down. So it gets to be kind of tricky to see that there's any change. So if you're playing with this value and adjusting your local rotation axis around your primary axis of motion, it can be hard to see. But if we grab Z instead, and if I orient the camera like so, you'll see that Z actually runs from left to right. As I start to increase Z, take a look at what our fire starts doing. It's actually curling around. And if I pull this up to around 5 or so, we're getting a nice, just about full curl on our fire. And that's because we're taking this axis that, again, if I orient like so, runs from left to right, and we are telling the particles to start orbiting that axis. Now, if I take this and combine it with a little bit of x, we can start getting a really cool kind of swirl through space. We start curling around. And we can add a little bit of y in for good measure and start getting all kinds of interesting effects. But I'll go ahead and leave that at 0. So we're kind of curling through this constant direction like so. Now, we do have world and we have local. Now, these two rotation axes do the same thing. It's just one is going to be relative to the local rotation axis of the emitter and the other one is not. The reason this can get a little bit on the confusing side is that it combines with the motion you've already imparted to your emitter. So if you're using local rotation, you're already going to get a change as you rotate your emitter, even if your local rotation axes are world. So here's an example. I'll just kind of point this out. We already saw in a previous video where world velocity does not change as you rotate the emitter. It's just going to send your particles down a world axis, and that will always be locked in. Well, world rotation axis is exactly the same way. It's going to cause your particles to orbit around a constant world axis. And because our local object is oriented with the world, right now it looks pretty much the same as it did a moment ago. However, if I was to rotate my emitter right now, we start getting some different behavior. Not much different. You'll see that our motion is still applied right down that axis, but it does start to update slightly.
Right.
Depending on which direction we fire the particles into.
Even though we are working with the world rotation axis.
That's right. This axis of orbiting, this axis of rotation, is never actually changing. What is changing while we rotate is the direction in which we're emitting the particles, which can get a little confusing. To keep things simple on you, at least when you first get started, I would advise you only to use world if you are already using world velocity, and if you're using local velocity, then use local rotation axis. That'll keep things a lot simpler for you. So let's go ahead and set this back to 0. And let me jump back over here to our emitter, and I'm going to 0 out its rotations up inside the transform. And now if I take my local rotation axis, and let's just set x and z to 5 to get that kind of curly Q look. We'll leave y at 0. And now as I rotate this, because we are using local velocity and we're using local rotation axis, we get the same shape that we can just reorient by rotating our emitter around. So that's how that works. Again, it just allows you to spin your particles around a particular axis and is very cool for highly unrealistic but still very cool looking effects. I guess it would be neat though if you had something like a little tornado or a dust devil or something and you need some particles to start kind of revolving around the base. This is a great way to pull that off. But of course for an effect like this it's a little unnatural. But that will wrap things up for this video. Thanks for watching.